Another way that we can associate things, aside from a Venn diagram, is what we call a contingency table. And that is just simply a way of putting our information together in some sort of table format. And so we're going to look at this. We have 200 students that took um, courses at a community college. So that's our total. I'm going to put in our 200. So we took care of this piece. 120 of them took psychology. So 120 of them took psychology. So here's our psychology part. With 25 of them not passing the final exam. So did not pass the final exam. Psychology is 25. That there. And 170 of the total students passed the final exam. So here's our pass the final exam row, and we have 170 of them that passed the final exam. Okay, so now we want to, so that's what information is given to us. Now we want to fill in the missing values. And so we have 200 and 120. So since this is the total, we know that there needs to be 80 students here. 120 and 25. So we know that these two rows have to add together to give us a 120. So we have 95 students here. We have 95 students here, 170 total students. That gives us 75 students in this box. 80 students and 75 students. That means we have 5 students missing here. 25 and 5 has to be our 30. 170 plus 30 gives us 200. So now we have both the table and the missing values for our table. So now we can answer some questions based on the table. So how many students did not pass the math final exam? So the math final exam is, or the math students are in this column, this, and then how many did not pass the math final exam? So did not pass, so that's going to be this 5 right here. What percentage of the total students passed a final exam? So the total that passed were 170 out of a total of 200, which is going to give us 85%. So that's a percentage of the total students. And then here's another probability question. It's similar to the percentage question of total students. So what's the probability that a student took a psychology course? So we had 120 students take a psychology course out of 200 students. So that would be the probability in that case. And again, we're going to talk more about probability in a future lesson. So create a two-circle Venn diagram from the table that we're talking about. So again, I'm going to try and make my two circles. And I got to figure out what am I going to name my two circles. So I'm going to go back to the information that was given to me at the very beginning. So I know something about psychology, and I know something about not passing a final. And I know that we had 120 students took psychology, so we have 120 students. We don't have the total that did not pass just from the information. We do know how many passed the final, which was 170, so I guess we do know that 30 students did not pass the final. All right, so 25 of them let's see, 25 of them did not pass or took psychology that did not pass it. So there's that 25 from this box here. Let's see about this. Let me change this color so that we have 25 students that did not pass. We also had 120 total students, so that leaves us 95 students that fills in this remaining circle. We know that 30 total students did not pass, so we had a 25 already, so that leaves us with 5 students. And then on the outside, we know that we're supposed to have 200 total students, and so 95 plus 5 is 100, 125, so it leaves us with 75 remaining students. And so these would be the math passing students. So this is math passing. And if you notice that each one of these numbers is also what's inside this portion of the table. So that's how your Venn diagram table is associated with this contingency, or your Venn diagram is associated with your what we call a contingency table. Now I want to look at this problem on the bottom of page 4, which is called the dog problem. And in this problem, we have 24 dogs in a kennel, so 24 total. 12 are black, 6 have short tails, and 15 have long hair. We also know there's one dog that is black with short tail and long hair, so one that has all traits. 2 dogs are black with short tails, but do not have long hair. But not long hair. And finally, we also have 2 dogs that are short tails with long hair, but not black. All right, so the other thing, let's see, if all the dogs are in the kennel, so we know that they're all going to be accounted for, so we don't have anything on the outside. How many dogs are black, long hair, but do not have short tails? So let's see how this looks in a Venn diagram. So this time I'm going to try and make 3 circles. All right, so we have black, and that's 12. We have short tail, and there are 6 of those. And we have long hair, and there are 15 of those dogs. Okay, so we have each one of these accounted for. One that has, make that area very big, but has all the traits. Now we have to be careful with this one. So this time it's 2 that are black with short tails, but not long hair. So black short tail, so that would be this whole region here, would be 2. And so we would put a 1 right here, but it's also saying not long hair. So we know that the 2 is just in that region right here. And then 2 with short tail, so short tail with long hair, so that's this again, this overlap, but not black, so I don't have to worry about that 1 right there, so I know this is a 2. And so we have 2, 4, 5, so that leaves us with 1 here. What we don't know is the black with long hair, so black, long hair, but not a short tail. So this is what we don't know. That's the number of dogs we don't know. So if we already know that this black circle should be 12, well, 12, 11, 10, 9, we know that there's 9 minus whatever this D is going to be, because we would have to subtract that out too. Same thing with our long hair. The only long hair dogs would be 15 minus 2 minus 1 minus whatever D is. And so 15 minus 2 minus 1 is 12 minus what we don't know. All right, so now all we need to do here, so let's add up just the numbers and see where that gives us. So if we have 9 plus 2 plus 1 plus 1 plus 2 plus 12. So this is just the numerical values, 9, 2, 1, 1, 2, and 12. So if we add up those regions, we know, remember, all 24 dogs sit in this circle, in these circles. There's nothing on the outsides. We have a total here of 27 dogs. But we know that we're only supposed to have 24 dogs. So that means 3 dogs are the overlap or overcounted. We've overcounted 3 dogs in both here and here. So that means D equals 3 dogs. So those are 3 black with long hair, but not a short tail.